Tonight, we're going far beyond our sun, to worlds that burn, freeze, wander, and glow in alien skies. Planets that rain molten metal, planets drifting alone through the darkness, and planets that may be just like Earth. Some are being swallowed by their stars. Some are shining like mirrors in deep space. And some might already be home to life. As you relax, let's drift through the strangest exoplanets ever discovered, and imagine what it would be like to stand beneath their skies. Hello, and welcome back to Dreamy Science Stories. If you find comfort in thinking about distant stars, quiet cosmic worlds, and the gentle vastness of space, you've arrived at the perfect place to unwind. Tonight, we're going to drift far beyond our familiar solar system. We'll travel into the deep darkness between the stars, where strange planets circle distant suns and reality often feels more surreal than fiction. Out there, worlds exist that rain molten metal, planets that may be built from diamond, and lonely giants wandering through space without a star to call home. Some of these stories may sound like fantasy, but every one of them is rooted in real astronomical discoveries. And if you enjoy these calming journeys, you're always welcome to like and subscribe. It helps other sleepy travelers find their way here too. For now, settle into a comfortable position. Let your muscles soften. Let your thoughts slow down. And together, let's begin our gentle voyage into the wonders of alien worlds. Glowing star planets that are hotter than some stars. We often think of stars as the ultimate furnaces of the universe, massive spheres of glowing plasma burning at millions of degrees. Yet, surprisingly, some planets come astonishingly close to stellar temperatures. One remarkable world is KLT-9b, an ultra-hot gas giant that reaches temperatures above 7,000 degrees Fahrenheit. That's hotter than many small red dwarf stars. This planet orbits incredibly close to its bright blue star, completing a full orbit in just a little over a day. KLT-9b is tidally locked, meaning one side always faces the star. That side is blasted by relentless radiation, while the other side remains in eternal night. The heat is so extreme that molecules break apart, atoms become ionized, and metals like iron and titanium can exist as vapor in the atmosphere. Its atmosphere is literally being torn away, stretching out into space like a glowing comet tail. These extreme worlds blur the line between what we call a planet and what we think of as a star. They challenge our understanding of planetary physics and remind us that the universe often defies our expectations. Gemstone planets that may be made of diamond. Some exoplanets might be rich in carbon, and under the right conditions, that carbon could crystallize into diamond deep beneath their surfaces. Imagine a world where pressure and heat transform carbon into vast underground layers of crystalline gemstone. One famous candidate is 55 Cancri, a super-Earth roughly twice the size of our planet. Scientists believe it may contain enormous amounts of carbon, and under immense pressure, that carbon could form diamond-like structures in its interior. This wouldn't be a sparkling jewelry box in space. There would be no glittering sunlight, no shimmering gemstones on the surface. Instead, there would be darkness, crushing pressure, and unimaginable heat. But still, the idea of a diamond planet captures the imagination. A world forged from cosmic carbon, shaped into crystal by time and gravity. Sunrise worlds with two suns. Science fiction has long dreamed of planets with twin sunsets, where two stars hang in the sky like glowing lanterns. Today, we know such planets truly exist. These are called circumbinary planets, and they orbit two stars at once. The stars themselves orbit each other, and the planet travels around them both in a complex, graceful dance. From the surface of such a world, the sky might glow with two dawns and two dusks. Shadows would shift in strange directions. Seasons could be unpredictable and dramatic. Some circumbinary systems are delicate, balanced by gravity in intricate ways. Yet, despite their complexity, they are real. a vision once imagined in science fiction now quietly confirmed by astronomy. Cloud with rain planets where it rains molten glass. Some planets are so alien that even their weather feels unreal. Take HD 189733b, a massive gas giant with temperatures around 1,700 degrees Fahrenheit and winds that scream around the planet at thousands of miles per hour. In its atmosphere float tiny particles of silicon dioxide, the building blocks of glass. When conditions are right, these particles condense and fall as rain. Not rain as we know it, but molten glass, driven sideways by supersonic winds. From far away, HD 189733b looks softly blue, almost peaceful, like a distant ocean world. But up close, it is a raging storm of fire and glass, a planet-sized furnace sculpted by violent winds. Waterwave endless ocean worlds. Some exoplanets may be covered entirely by water, with no continents, no mountains rising above the sea. Just a global ocean stretching from pole to pole. On these worlds, the oceans could be hundreds or even thousands of miles deep. Near the surface, waves and clouds might resemble Earth's oceans. But far below, the pressure would become extreme, creating exotic forms of ice that exist only under crushing conditions. Deep beneath the water, some planets might have rocky cores warmed by internal heat, possibly creating warm layers beneath the ice. Scientists wonder whether life could exist in such vast alien oceans. Ocean worlds may be more common than we once thought. Quiet, shimmering spheres turning slowly in the dark, their surfaces reflecting distant starlight. Last quarter moon tidally locked planets. Eternal day and eternal night. Not all planets rotate like Earth. Some are tidally locked, meaning one side always faces their star while the other remains in permanent darkness. Imagine a world with a blazing day side and a frozen night side. Between them lies a narrow twilight band where temperatures might be moderate, a ring of eternal dusk. Some scientists believe that if life exists on tidally locked planets, it might thrive in this twilight zone, where light and darkness meet. Winds would roar from the hot side to the cold side, creating dramatic weather patterns and strange cloud formations. Fire-hot Jupiters skimming their stars. Hot Jupiters are massive gas giants that orbit incredibly close to their stars. Their years last only a few days, and their atmospheres boil under intense heat. Some of these planets are slowly losing their atmospheres, blown away by stellar radiation. Others leave glowing trails of gas behind them like cosmic comets. How they formed so close to their stars remains a mystery. Did they migrate inward from distant orbits? Were they pushed by gravitational interactions with other planets? They are dramatic, unstable worlds, brief cosmic flames circling distant suns. New moon planets darker than coal. Not all planets reflect light. Some absorb nearly everything, becoming darker than charcoal, darker than asphalt, darker than almost anything we can imagine. One such planet reflects less than 1% of the light that hits it. Its atmosphere may contain exotic chemicals or vaporized metals that swallow incoming light. If you could see such a planet, it might appear as a nearly invisible shadow against the brightness of its star. A dark silhouette silently circling in space, absorbing the universe's light. Milky Way rogue planets, wandering alone. Most planets orbit stars, but some wander alone through the galaxy. These are rogue planets, free-floating worlds that drift through space without a sun. They may have formed in planetary systems and been ejected by gravitational chaos, or they may have formed in isolation like failed stars. Rogue planets are cold, dark, and incredibly difficult to detect. Some may have thick atmospheres or internal heat, possibly allowing subsurface oceans beneath layers of ice. They travel silently through interstellar space, carrying their mysteries across the galaxy like cosmic nomads. But with powerful infrared telescopes, astronomers can catch faint hints of their thermal glow. Even without a sun, Some rogue planets may still hold on to internal heat left over from their violent birth. That warmth could keep hidden oceans liquid beneath thick shells of ice for billions of years. Others, though, may be completely frozen, silent spheres drifting endlessly through interstellar darkness. A planet without a sunrise, a world without a sky. No stars overhead, no day or night, only endless black. And yet, even in that stillness, a quiet question remains. Could something live there? Life tucked away in darkness, warmed by invisible heat, dreaming beneath alien ice. Gemstone skies filled with ruby and sapphire clouds. When we think of clouds, we imagine soft white shapes made of water vapor. But on some exoplanets, clouds may be formed from minerals and metals instead of water. On scorching gas giants where temperatures rise above 2,000 degrees, rocks can vaporize and rise into the atmosphere like steam. Aluminum oxide, iron, titanium, and even corundum, the mineral that forms rubies and sapphires, can condense into shimmering clouds high in the sky. These mineral clouds scatter light in strange and beautiful ways, tinting the atmosphere with deep blues, purples, and crimson reds. On planets like WASP 7b, astronomers have detected shifting atmospheric patterns that suggest clouds of these exotic minerals drifting across the globe. Imagine a sky glowing with gemstone colors, storms swirling with molten minerals, and sunlight refracting through clouds of liquid crystals. The universe paints with materials far stranger than we ever imagined. Globes showing Europe-Africa super-Earths that could be more habitable than Earth. Not all alien worlds are hostile infernos. Some exoplanets fall into a category called super-Earths, rocky planets larger than our own, but smaller than Neptune. These planets may have stronger gravity, thicker atmospheres, and more stable climates. Some might even be better suited for life than Earth. One intriguing candidate is Kepler 442b, a rocky planet located in the habitable zone of its star. It receives a gentle amount of starlight, not too hot, not too cold. Its size suggests it could hold onto an atmosphere and possibly liquid water. Some super-Earths may have fewer volcanic disruptions, deeper oceans, and more stable tectonic conditions, giving life a longer, calmer window to emerge and evolve. We don't yet know if any of these planets truly host life, but they remind us of something humbling. Earth may not be the perfect planet. It may simply be the one we were born on. Stopwatch planets that orbit in just a few hours. Most planets take months or years to orbit their stars. Earth takes 1 year. Mercury takes 88 days. But some exoplanets move unimaginably fast. One such world is Kepler 78b, a planet only slightly larger than Earth that completes a full orbit in just 8.5 hours. It is so close to its star that its surface is likely a sea of molten rock. The star fills much of the sky, glowing enormous and fierce. Gravity pulls strongly on the planet, stretching it, heating it, and possibly tearing it apart over time. These ultra-short period planets are often tidally locked, with one side permanently facing the star. Their days and nights are frozen in place. They race around their suns like sparks flying from a cosmic flame, brief, bright, and extreme. Turtle planets that take centuries to orbit. While some planets sprint around their stars, others move with breathtaking slowness. One example is Piscium b, a massive gas giant that takes roughly 1,000 years to complete a single orbit. It drifts so far from its star that it is barely held by gravity. On such worlds, seasons might last lifetimes. Generations could pass before the sky changes. Starlight would be faint, and the cold would be deep and constant. These planets are incredibly difficult to detect. We can't wait centuries to watch their orbits, so astronomers look for subtle motions, tiny arcs across the sky, gentle gravitational hints. On these worlds, time flows differently. Change happens slowly, silently, almost imperceptibly. Shooting star thousands of planets beyond our solar system. For most of human history, we believed our solar system was unique. Then, in the 1990s, the first exoplanets were confirmed. Today, thanks to missions like Kepler and TESS, we have discovered thousands of planets orbiting distant stars. Some are rocky and Earth-like. Others are giant, strange, and unlike anything in our solar system. We now believe there may be hundreds of billions of planets in the Milky Way alone. Possibly more planets than stars. Worlds beyond counting, quietly orbiting suns we will never reach. But we can listen for them, measure their shadows, and wonder. New moon detecting planets through shadows. One of the most powerful ways we find exoplanets is by watching stars dim. When a planet passes in front of its star from our viewpoint, it blocks a tiny fraction of the light. This is called the transit method. The dip in brightness may be less than 1%, but it is enough to reveal the planet's size and orbit. Sometimes, astronomers can even detect molecules in the planet's atmosphere. We are watching stars blink, tiny flickers that reveal unseen worlds drifting silently in front of distant suns. Musical notes detecting planets through stellar wobbles. Planets also reveal themselves through gravity. When a planet orbits a star, it tugs on the star slightly, causing it to wobble. This motion changes the star's light in subtle ways. By analyzing the spectrum of starlight, astronomers can detect these shifts. This technique is called the radial velocity method, and it helped discover the first known exoplanets. We are not seeing the planets directly. We are watching their stars dance. Wind-face atmospheres escaping into space. Some planets are slowly losing their atmospheres. Intense radiation from nearby stars heats their upper layers until gas escapes into space, forming long glowing tails like cosmic comets. Over millions or billions of years, a gas giant could shrink, leaving behind a rocky core. Stars can sculpt their planets, stripping them down and reshaping entire systems. Even planets are not permanent. They change, erode, and fade, cosmic stories written in gas and gravity. Some face worlds with multiple suns. Some planetary systems contain not one, but 2 or 3 stars. And astonishingly, planets can exist in these complex systems. Imagine a sky with multiple suns, rising and setting at different times. Shadows would stretch in strange directions. Light would come from several points in the sky. Nights might never be fully dark. These planets must follow delicate gravitational paths to remain stable. Yet they survive, tracing elegant orbits around chaotic stellar dances. In such skies, the stars never stand still. Comet planets orbiting dead stars. Stars do not live forever. Some end as white dwarfs, dense glowing remnants of once bright suns. In rare cases, planets orbit these stellar corpses. These worlds would receive faint, ghostly light from their dying stars. Their skies would glow dimly, illuminated by the quiet embers of a stellar life long gone. Even after a star dies, planets may continue to circle its remains, silent witnesses to cosmic history. Some stars don't fade quietly. They explode, collapse, or tear themselves apart in violent cosmic finales. And yet, even after a star dies, planets can remain. Around neutron stars, white dwarfs, and even black holes, astronomers have found worlds still tracing their silent orbits. These planets exist in the aftermath of stellar death, circling glowing embers or pulsating remnants of once brilliant suns. Some of them survived the chaos of a supernova, enduring shockwaves that would shred most structures in the universe. Others may have formed later, born from the debris of destruction, rising from cosmic ashes like phoenixes in the void. The light from their stars is faint, distorted, or eerie, casting dim illumination across alien landscapes. Some are bombarded with deadly radiation, while others drift in perpetual twilight, never knowing a true day or night. These planets move through what could be called a stellar graveyard, haunting, beautiful, and a powerful reminder that endings in the universe often give rise to new beginnings. One planet defies expectations in an entirely different way. It orbits its star backwards. Most planets follow the same direction as their star's rotation, because solar systems usually form from a spinning disk of gas and dust. But nature doesn't always follow neat patterns. The exoplanet WASP 17b is one such rebel. It travels in the opposite direction, pushing against the spin of its star as if swimming upstream through cosmic currents. This strange orbit likely resulted from a violent past, perhaps a near collision with another massive body, or a gravitational tug-of-war that rearranged the entire system. WASP 17b is enormous, bloated, and blisteringly hot, hugging its star so closely that it completes an orbit in just a few days. Its backward motion challenges everything we thought we knew about how planetary systems form. It's proof that the universe is not a rigid machine, but a chaotic, creative force. Some planets follow the flow, others resist it, and a few move through space in quiet defiance. We've also detected clouds on planets dozens, even hundreds of light years away. We can't see these clouds directly, but we can read their signatures in starlight. When a planet passes in front of its star, some of the star's light filters through the planet's atmosphere. By analyzing which wavelengths are absorbed or scattered, scientists can identify gases, particles, and even cloud layers. These aren't fluffy white clouds like Earth's. Many are made of vaporized metals, silicates, or exotic chemicals, clouds of molten glass, iron droplets, or mineral dust. Some planets may be permanently shrouded in thick cloud cover, while others show dynamic weather patterns that shift over time. We are essentially reading alien weather forecasts from light alone, deciphering storms and skies across unimaginable distances. Some exoplanets orbit so close to their stars that Mercury would seem distant by comparison. Mercury is already scorched by our sun, yet many discovered planets orbit even closer to their stars, where temperatures can melt rock and boil atmospheres away. These worlds may complete an orbit in just a few hours. Their surfaces could be oceans of magma, and their atmospheres stripped by fierce stellar winds. Many are tidally locked, with one side permanently facing the star in eternal daylight, while the other remains locked in endless darkness. Others are stretched into distorted shapes by tidal forces, pulled into teardrops by their star's gravity. These extreme planets are hostile and unstable, but they're also among the easiest to detect, which is why many of the first exoplanets we found belong to this fiery category. They remind us that planetary systems can be far more extreme than we ever imagined. Yet some planets live in the opposite extreme, far beyond the reach of sunlight. Not all planets cling tightly to their stars. Some orbit at enormous distances, where starlight becomes a faint whisper. These distant worlds may take centuries or even millennia to complete a single orbit. Temperatures drop to unimaginable lows, and seasons stretch across generations. But even here, planets endure. Some may be icy giants wrapped in frozen clouds, while others could be rocky, barren spheres coated in carbon dust and ice. A few might harbor hidden warmth beneath their surfaces, powered by radioactive decay or ancient heat trapped since their formation. These lonely planets exist on the fringes of gravity itself, proving that worlds can survive in places we once thought empty and lifeless. There may also be planets with ring systems far more spectacular than Saturn's. Saturn's rings are iconic, but they might be modest compared to what exists elsewhere in the universe. Some exoplanets appear to have enormous ring systems, stretching hundreds of times wider than Saturn's, large enough to eclipse their host stars. One candidate, J1407b, may possess a ring system so vast it would dominate the sky if placed in our solar system. These rings could be made of ice, rock, and dust, possibly forming moons in slow motion. As the planet passes in front of its star, The rings create complex dips in starlight that astronomers can detect. For now, these systems remain partly hypothetical, but they hint at a level of cosmic grandeur that dwarfs anything we see around our sun. And despite everything we've learned, we are still only at the beginning. The first confirmed exoplanets were discovered in 1992, just a moment ago on cosmic timescales. Since then, we've found thousands more, and thousands still await confirmation. We've measured their sizes, mapped their orbits, detected their atmospheres, and even glimpsed their skies through light and shadow. But we still can't walk on these worlds. We don't know what they smell like, sound like, or feel like beneath our feet. We don't know which ones have oceans, mountains, storms, or life. Every new discovery is a doorway into something completely unknown, and with each improvement in technology, the universe becomes more complex, more mysterious, and more breathtaking. Some planets orbit so close that they are literally being destroyed. For certain exoplanets, proximity to a star is a death sentence. Intense radiation and stellar winds heat their atmospheres until they expand and escape into space. Some develop glowing tails of gas and dust, trailing behind them like comets locked in eternal orbit. Over time, these planets shrink, erode, and transform, slowly losing their mass to the star they orbit. One world, K2-22b, may be crumbling under this process, shedding material with every orbit. Watching these planets is like witnessing a world dissolve in real time, a reminder that even planets are not permanent. They are shaped, sculpted, and sometimes destroyed by the cosmic environments they inhabit. And time and again, the universe surprises us. We've found planets with skies filled with vaporized metal, rocky worlds hotter than lava, and gas giants colder than deep interstellar space. Some planets spin on their sides, some move backwards, and some have rings so large they could blot out a star. Some are impossibly dense, others unbelievably fluffy. Many shouldn't exist according to our theories, yet they do. Every strange discovery forces scientists to rewrite their models, rethink their assumptions, and expand the boundaries of what is possible. The universe is not a tidy textbook. It's a living laboratory filled with anomalies, contradictions, and cosmic puzzles waiting to be understood. Some exoplanets may be water worlds with no land at all. Imagine a planet with no continents, no islands, no shorelines, just a global ocean stretching endlessly in every direction. These water worlds could have oceans hundreds or thousands of kilometers deep. Beneath their surfaces, pressures would be so extreme that water forms exotic ice phases, and rock behaves in unfamiliar ways. In such depths, sunlight would never reach. Alien ecosystems, if they exist, would rely on internal heat, chemical energy, or unknown processes. These planets challenge our ideas of habitability, suggesting that life could exist in environments far stranger than anything on Earth. Some of these ocean-covered worlds might be wrapped in thick atmospheres filled with steam, mist, and drifting clouds of vapor. Imagine a planet where the sky is always heavy with moisture, where warm currents rise from an endless sea, and dense clouds swirl overhead like a living ceiling. Other water worlds might be hidden beneath layers of fog, warmed either by faint sunlight filtering through the haze or by heat rising from deep within their cores. If life exists on such planets, it would not evolve under blue skies and sunshine like on Earth. Instead, it would grow in the darkness of deep oceans, shaped by currents, chemistry, pressure, and geothermal energy rather than light. Strange ecosystems could thrive around underwater vents, feeding on minerals and heat instead of sunlight. We haven't confirmed a true water world yet, but the evidence is mounting. And if Earth represents one type of habitable planet, then these dark, ocean-covered worlds may represent an entirely different category of life-bearing environments, alien, mysterious, and utterly unfamiliar. We've also discovered a vast population of planets that don't fit neatly into the categories we once knew. Between rocky Earth-like planets and gas giants like Neptune lies a strange class of worlds known as mini-Neptunes. These planets are larger than Earth, yet smaller than Neptune, often wrapped in thick envelopes of gas. Beneath their swirling clouds, they may have rocky or icy cores, hidden under layers of hydrogen, helium, and exotic gases. From a distance, they might resemble scaled-down gas giants, but inside, they could be radically different. Some might contain boiling oceans buried beneath dense atmospheres. Others might lack any solid surface at all, transitioning from gas to liquid to exotic supercritical states as you descend deeper. For decades, scientists weren't even sure such planets could exist. Now, we know they are among the most common types of planets in the galaxy. These swollen, mysterious worlds fill the gap between what we thought planets should be and what they actually are, reshaping our understanding of planetary diversity. Some planets are so inflated they resemble cosmic balloons. These are the puffy planets, giant worlds with incredibly low density. They are massive in size but surprisingly light, so light that if you could place them in a bathtub the size of a star, they might float. One famous example is WASP 17b, a gas giant nearly twice the size of Jupiter, but with only a fraction of its mass. Many of these planets likely formed far from their stars and later migrated inward. Once they moved close, intense stellar heat caused their atmospheres to expand, swelling them to enormous sizes. Radiation breaks apart molecules, creating strange chemical reactions, and sometimes producing glowing tails of escaping gas. Some of these planets appear almost translucent, their atmospheres stretched thin by light itself. We still don't fully understand why they puff up so dramatically, but they show that planets are not always solid, rigid spheres. They can be soft, swollen, and sculpted by radiation like cosmic balloons drifting in stellar fire. On some worlds, a single day lasts longer than an entire year. On Earth, we rotate once every 24 hours and orbit the Sun once every 365 days. But on certain exoplanets, especially those orbiting extremely close to their stars, the situation is reversed. These planets complete an entire orbit before they finish a single rotation. Many of them are tidally locked, meaning one side always faces the star while the other side remains in perpetual darkness. There are no sunsets, no sunrises, just an eternal day on one hemisphere and endless night on the other. Time itself becomes strange. A year races by in days, while a day stretches on forever. Imagine standing on such a world, watching the star frozen in the sky, never moving, while the concept of night becomes something that only exists on the far side of the planet. Some alien worlds may be hidden beneath thick, hazy skies. We often picture exoplanets with clear skies and spectacular views, but many could be cloaked in dense atmospheric haze. These hazes might be composed of complex hydrocarbons, photochemical smog, or exotic chemical clouds unlike anything on Earth. We see a hint of this on Saturn's moon Titan, where a thick golden haze obscures the surface completely. On distant exoplanets, ultraviolet light from their stars can trigger chemical reactions in the upper atmosphere, creating thick layers of haze that trap heat and scatter light. From space, these planets might appear muted, dull, or softly colored. But beneath the haze, oceans could churn, storms could rage, and alien landscapes could stretch across continents no one has ever seen. The haze is like a veil, hiding entire worlds in plain sight. We've also found evidence of winds traveling at unimaginable speeds. Weather exists far beyond Earth. On some gas giants, winds can reach speeds of thousands of miles per hour. Many of these planets are tidally locked, with one side constantly heated and the other side frozen, creating extreme temperature differences that drive furious atmospheric currents. Astronomers have detected winds moving at speeds exceeding 5,000 miles per hour, fast enough to cross a continent in minutes. These winds can move clouds, redistribute heat, and even carry vaporized metals across the planet. In some cases, the brightest part of the planet isn't where the star shines directly, but shifted by these winds. We can't see the storms, but we can read their signatures in light, tiny shifts in brightness that reveal the motion of alien atmospheres. Some planets may be heated from within, even without sunlight. Not all planetary heat comes from stars. Some worlds experience intense tidal heating, where gravitational forces stretch and flex their interiors, generating heat through friction. This is how Jupiter's moon Io stays volcanically active, and the same process can happen on exoplanets. Planets in eccentric orbits or gravitational dances with neighboring worlds can be squeezed and released repeatedly, turning their interiors into engines of heat. This internal energy could melt rock into magma, power volcanoes, or keep subsurface oceans liquid beneath thick ice shells. From the outside, these planets may look cold and dark, but inside, they could be geologically alive. Even far from a star, a planet can still be warm, dynamic, and active. We've discovered planets in star systems older than Earth itself. Some stars formed in the earliest chapters of the universe, billions of years before our sun existed. Around a few of these ancient stars, astronomers have found planets that have been orbiting for over 10 billion years. One such system, Kepler 444, hosts multiple small rocky planets around a star that formed when the galaxy was young. These planets formed in a universe with fewer heavy elements, meaning their composition could be very different from Earth's. They may be scarred by countless impacts, eroded by cosmic radiation, and shaped by billions of years of cosmic history. Could life have existed there long before Earth even formed? Could civilizations have risen and fallen in the deep cosmic past? We may never know, but these ancient worlds are cosmic elders, quietly circling their stars through the vast expanse of time. Some exoplanets may have moons we've only begun to glimpse. For every planet, there may be moons, but detecting moons around distant worlds is incredibly difficult. So far, exomoons remain elusive, but we've seen tantalizing hints, tiny wobbles in planetary orbits, unexpected dips in starlight, subtle signals that suggest something is there. One candidate moon around Kepler, 1625b, could be enormous, larger than any moon in our solar system. If confirmed, it would reshape our understanding of moon formation. Even smaller moons could play crucial roles, stabilizing planetary climates, generating tides, or hosting subsurface oceans. Some could resemble Europa or Enceladus, with hidden oceans beneath icy shells. Others could be rocky, cratered worlds drifting in the twilight of giant planets. And some planets may host entire systems of moons, miniature solar systems of their own. Just as stars host planets, giant planets can host dozens or even hundreds of moons. In our solar system, Jupiter and Saturn each have vast families of moons, from tiny captured rocks to worlds larger than Mercury. Now imagine a gas giant many times more massive than Jupiter, orbiting a distant star. It could have an entire system of moons, rocky, icy, atmospheric, ocean-covered, each a world unto itself. Some moons might orbit in the habitable zone of their parent planet, warmed by tidal forces and shielded from stellar radiation. Others could have thick atmospheres, lakes, or even weather systems. We haven't confirmed such moon systems yet, but the possibilities are staggering. Not just planets, but entire families of worlds drifting through space together, bound by gravity, each with its own story. Some exoplanets might support life, but not in ways we would recognize. When we imagine alien life, we often picture blue skies, liquid water, mild temperatures, and familiar biology. But life may not need any of those comforts. On some distant worlds, life could exist in environments that would be instantly lethal to us. Floating in acidic clouds, buried beneath kilometers of ice, or thriving in crushing atmospheres filled with methane or ammonia. Life might not even rely on carbon, water, or DNA. On Earth, extremophiles already survive in boiling acid, deep underground caves, radioactive waste, and volcanic vents with no sunlight. If life can endure here, it may find a way to exist in even stranger forms elsewhere. Not creatures that walk or speak, but microbial webs, chemical ecosystems, or self-organizing systems that replicate and evolve in silence. We may never see them directly, but one day we might detect a subtle chemical imbalance in a distant atmosphere, a faint whisper in starlight that suggests something is breathing, growing, and changing on a world far beyond our reach. Some planets exist right on the boundary between planet and star. There is no sharp line dividing planets and stars, only a gradual transition. Some objects sit in this in-between region, massive worlds known as super-Jupiters or brown dwarfs. They are so large that their cores can fuse small amounts of deuterium, yet not enough to ignite full stellar fusion. They glow faintly with residual heat from their birth, radiating in infrared like dying embers in the dark. One such object, HD 100546b, is so massive and hot that scientists still debate whether it is a giant planet or a failed star. Where does a planet end and a star begin? The answer isn't clear. These boundary objects may form like stars or assemble like planets, and sometimes we can't tell which path they took. They exist in the gray zone of cosmic classification, reminding us that nature rarely fits neatly into our labels. The universe is full of transitions, gradients, and blurred edges where one thing slowly becomes another. Some worlds sit right on the edge of the habitable zone. The habitable zone is often called the Goldilocks zone, the region around a star where liquid water could exist on a planet's surface. But many exoplanets lie right on the border of this zone, where conditions are precarious and unpredictable. A thick atmosphere could trap heat and keep a planet warm. A reflective surface or cloud cover could keep it cool. A tilted axis or elliptical orbit could produce extreme seasonal changes. One side of the planet might be habitable, while the other is frozen or scorched. Life, if it exists, might survive only in isolated pockets, beneath ice sheets, inside caves, or near geothermal vents. These edge worlds are neither fully alive nor completely dead. They exist in a delicate balance between warmth and cold, light and shadow, where small changes could tip the planet towards sterility or habitability. They are worlds on a knife's edge. We're beginning to read the chemistry of alien atmospheres. Until recently, analyzing the atmosphere of a planet light years away seemed impossible. But modern telescopes, especially the James Webb Space Telescope, are changing that. When a planet passes in front of its star, a tiny fraction of starlight filters through its atmosphere. That light carries the fingerprints of molecules, spectral signatures that reveal what the air is made of. By analyzing this light, scientists can detect water vapor, carbon dioxide, methane, sodium, and more. From these signals, we can infer temperature, pressure, cloud cover, and even hints of weather patterns. In the future, we may detect biosignatures, chemical combinations that suggest biological activity. It's like reading a message encoded in light, sent across the galaxy. With every new spectrum, we learn a little more about the skies of distant worlds we can never touch. Some exoplanets may have seasons that last for decades or centuries. On Earth, seasons are mild and predictable, caused by a gentle tilt of our planet's axis. But on other worlds, the tilt could be extreme, the orbit stretched, or the star system chaotic. Some planets may experience summers that last decades and winters that last entire lifetimes. A world might swing close to its star, heating dramatically, then drift far away into deep freeze. Others might have erratic seasons, shifting unpredictably due to multiple stars or gravitational interactions. Life on such planets would follow a very different rhythm. Entire generations might live and die within a single season. Time itself would feel different, shaped by long arcs of light and darkness rather than familiar yearly cycles. Some planets live forever in twilight. On tidally locked worlds, one side always faces the star and the other never does. Between these extremes lies a narrow band called the terminator, a region of perpetual dusk. Here, the sky would never be fully bright and never completely dark. Temperatures might be moderate, winds gentler, and conditions more stable. If life exists, it might thrive along this narrow twilight ring, adapting to the constant half-light. There would be no sunrise, no sunset, just a star frozen at the horizon, forever hovering at the edge of the sky. A planet where time stands still in shadow and glow, where night and day are concepts that never fully arrive. Some planetary systems move in perfect gravitational harmony. In certain star systems, planets orbit in synchronized rhythms known as orbital resonances. For every 2 orbits one planet makes, another completes 3. These ratios create a stable gravitational dance that prevents collisions and keeps the system orderly. We see this in our solar system among Jupiter's moons, but we've also discovered entire chains of exoplanets locked in resonance. 3, 4, even 6 planets moving in precise patterns, like instruments in a cosmic orchestra. These configurations are delicate. A small disturbance could disrupt the harmony. Yet they persist for billions of years, proof that the universe can be both chaotic and beautifully ordered. Some planets show signals we still cannot explain. Not everything we observe fits our models. Some exoplanets produce strange light curves, dimming and brightening in irregular patterns. Others show unusual dips that suggest rings, clouds, debris fields, or unknown structures. One famous example is Tabby's star, which dimmed in unpredictable ways and sparked global speculation. While natural explanations remain most likely, the mystery highlighted how little we understand. Some planets appear to trail dust. Others seem to change shape or brightness over time. We're slowly decoding these signals, but many remain puzzles, subtle flickers in starlight that hint at complex, dynamic worlds beyond our current understanding. Some planets follow wild, elongated orbits that almost escape their stars. Most planets travel in calm, nearly circular paths. But some exoplanets have highly eccentric orbits, swinging far away from their stars before plunging back in. At their farthest point, they are frozen and dark. At their closest, they are blasted by intense heat and radiation. These journeys can take hundreds or thousands of years. Some of these planets were likely thrown into such orbits by gravitational interactions or passing stars. Others may one day be ejected entirely, becoming rogue planets drifting through interstellar space. They are cosmic nomads, barely held by gravity, their futures uncertain. Some planets orbit the burned-out remains of dead stars. When a star like our Sun dies, it leaves behind a white dwarf, a dense, glowing ember of stellar matter. These remnants no longer fuse hydrogen, but they remain hot for billions of years, slowly cooling in the darkness. Around some white dwarfs, astronomers have discovered planets. These worlds either survived the violent death of their star or formed from the debris left behind. Imagine a planet orbiting a stellar corpse, illuminated by a dim, ghostly light. A sky filled with a small, intense white sun, casting strange shadows across a cold, quiet world. These planets are reminders that even after a star dies, planetary systems can endure or be reborn from the ashes. And around some of these stellar remnants, planets still endure. Around the glowing corpses of dead stars, astronomers have discovered planets that somehow survived the violent transformation of their suns. Some remained close, enduring the phase when their star expanded into a red giant, engulfing inner worlds and tearing apart orbits. Others may have formed later, condensing from the debris left behind after the star shed its outer layers. The environment near a white dwarf is harsh beyond imagination. Radiation can be intense. gravity can be crushing. The stellar remnant itself is small but incredibly dense, warping space and time around it. Yet, planets persist even here. Some may even orbit in the narrow zone where temperatures allow liquid water to exist. These worlds circle the dead, but they themselves are not lifeless. They are survivors, echoes of a system that refused to vanish. Proof that even after stellar death, planetary stories can continue. Some worlds may be rebuilt from cosmic wreckage. In young planetary systems, chaos reigns. Collisions between worlds are common. Moons are torn apart. Planets crash, shatter, and scatter their remains across space. But from this destruction, new planets can emerge. Astronomers have observed dusty disks around stars where gaps and rings suggest violent collisions and ongoing formation. Some exoplanets may be stripped cores of once larger worlds, their atmospheres blown away by radiation or impacts. Others may be conglomerates, assembled from fragments slowly pulled together by gravity. These are recycled planets, reborn from cosmic debris. Their surfaces may be fractured and molten, their orbits tilted and unstable. But they exist, and they remind us that in the universe, destruction is not always an ending. Sometimes it is simply the beginning of something stranger, tougher, and more resilient. Some planets may have been stolen from other stars. Planets are born around stars, but stars themselves move through the galaxy. Over billions of years, close encounters between stars can occur, especially in crowded clusters. In these encounters, planets can be stripped from their original systems and captured by another star. These interstellar adoptees may end up on odd, tilted, or highly eccentric orbits. Their chemistry or motion may hint that they don't belong. They are cosmic immigrants, torn from one family and adopted by another through gravity and chance. Solar systems are not sealed bubbles. They exchange material, lose worlds, and sometimes gain strangers. The galaxy is a vast network of drifting systems, occasionally trading planets in silent gravitational exchanges. Some exoplanets may resemble the early Earth. When we study distant worlds, we're also looking back at possible versions of our own past. Some exoplanets may resemble Earth billions of years ago, when the atmosphere was thick with methane and carbon dioxide, and oxygen was rare. These planets may still be forming continents, building atmospheres, and undergoing violent geological change. Volcanoes could shape their skies. Storms could rage across newborn oceans. Chemical reactions could be laying the groundwork for life. Studying these worlds could help us understand how Earth transformed into the habitable world we know today. What did our skies look like before oxygen filled the air? What storms raged over early seas? Some exoplanets may be living snapshots of that ancient chapter, distant echoes of Earth before humans ever existed to witness it. Giant planets can orbit tiny, dim stars. Most stars in the galaxy are red dwarfs, small, faint, and long-lived. Yet around some of these quiet embers, astronomers have discovered enormous planets, sometimes as large as Jupiter. At first, this seems unlikely. How could such a small star form and hold such a massive world? But nature often defies expectations. These giant planets often orbit extremely close to their stars, completing orbits in just a few days. The contrast is striking, a colossal planet looming beside a faint, ember-like star. These systems challenge our theories of planet formation and show that even modest stars can host dramatic, oversized worlds. In the quiet corners of the galaxy, strange configurations still emerge. Some stars host crowded systems with many planets. Our solar system has 8 planets, but some stars may host far more. Missions like Kepler and TESS have revealed compact systems with 5, 6, or even 7 confirmed planets, often packed tightly together. In these systems, planets orbit closer to their star than Mercury does to the Sun. From the surface of one world, another planet might appear large and bright in the sky, not a point of light, but a visible disk. Their orbits are often synchronized in delicate resonances, like gears in a cosmic clockwork. These crowded systems challenge our sense of what a planetary system should look like. They suggest that the architecture of planets is as diverse as the stars themselves. Some stars may host only a single lonely planet. At the opposite extreme are systems with just one known planet, a solitary world orbiting its star alone. Perhaps other planets were ejected, destroyed, or simply too small to detect. But what remains is a single traveler tracing a quiet path through space. These lonely worlds may have stable, peaceful histories, or violent pasts that strip them of companions. Their skies might feel empty. No nearby planets rising like moons. No gravitational companions shaping tides or seasons. Just one planet and one star moving together through the darkness. It is a quiet kind of beauty, a solitary rhythm in a universe filled with crowds. Some exoplanets may be wrapped in endless steam. Imagine a world where the surface is hidden beneath thick layers of hot vapor. Some exoplanets likely have atmospheres dominated by water vapor, created by extreme heat that boils oceans into the sky. These steam worlds orbit close to their stars, where liquid water cannot survive on the surface. Instead, the planet becomes wrapped in a global fog, a dense, glowing shroud that hides everything below. Deep beneath the haze, liquid water or a rocky surface might still exist, buried under crushing pressure. These are transitional worlds, where the boundary between ocean and sky disappears, and the planet becomes a swirling sphere of vapor and heat. On some planets, ice can behave like rock. On Earth, ice is fragile and melts easily. But under extreme pressure, water ice can transform into exotic crystalline forms that are dense and incredibly strong. On some exoplanets, especially icy super-Earths, these high-pressure ices may form thick layers beneath deep oceans. They may behave like solid rock, forming mountains, crusts, and tectonic-like structures. Beneath these frozen layers, liquid oceans could still churn, warmed by internal heat. On such worlds, glaciers may never melt. Ice mountains may last for billions of years. The line between geology and water becomes blurred. Some planets may be coated in exotic ices. Not all ice is made of water. On distant, cold exoplanets, substances like ammonia, methane, and nitrogen can freeze into solid ices. These exotic frosts may cover the surface in pale colors, blue, pink, or yellow, under a dim and distant star. These ices may form smooth plains, glittering ridges, or drifting clouds of frozen particles. Some may slowly sublimate, creating thin atmospheres that rise and fall with the planet's orbit. These are alien landscapes, chemically and visually unlike anything in our solar system. Some of these frozen worlds may remain stable for billions upon billions of years, quietly drifting through the galaxy without ever melting or changing. They could look somewhat like Pluto or the icy moons of Neptune, but on a far grander and more dramatic scale. Imagine enormous planets entirely sculpted by chemistry, where frozen gases and exotic compounds carve valleys, plains, and towering ridges across the surface. The atmosphere on such a world might be thin, unfamiliar, and faintly glowing under distant starlight. The sun above would appear as a tiny, dim point, barely warming the landscape. And yet, in their stillness and silence, these icy giants may be among the oldest travelers in the cosmos, ancient witnesses to the long evolution of the galaxy itself. We have also discovered planets in the crowded star clusters where stars are born. Most stars do not form in isolation like our sun, but in bustling nurseries packed with hundreds or even thousands of newborn stars. For decades, scientists doubted that planets could survive in such turbulent environments. Powerful radiation, chaotic gravitational forces, and close encounters with neighboring stars seemed likely to tear young planetary systems apart. But nature surprised us once again. We now know that planets can indeed form even in these crowded cosmic cities. Some of these exoplanets orbit their stars while nearby suns blaze with intense ultraviolet light. Their atmospheres may struggle to survive, or they may form quickly before the surrounding chaos can disrupt them. Some are ejected, becoming wandering rogue planets lost between the stars. Others manage to hold on, circling their suns despite the turmoil. From their surfaces, the night sky would be dazzling, filled with countless bright stars shining far more vividly than anything visible from Earth. These environments are dangerous and dynamic, yet planets persist. And where planets exist, the possibility of life can never be completely ruled out. Many exoplanets have formed in places we once thought impossible. Early planet hunters expected other planetary systems to look like ours, with rocky worlds close to the star and gas giants farther away, all following calm and orderly orbits. Instead, we found a universe full of surprises. Some planets formed in systems with 2 or even 3 stars. Others orbit pulsars, the spinning remnants of exploded stars that blast radiation into space. Some formed in environments poor in heavy elements, where scientists once believed planet formation could not occur at all. In every case, reality proved more imaginative than theory. Planet formation is not fragile. It is adaptable. Wherever dust and gas exist, gravity begins its slow, patient work, pulling particles together, forming clumps, and building worlds even in the aftermath of cosmic destruction. Perfect conditions are not required. Time and gravity are enough. We have even detected planets around stars that are only a few million years old, cosmic infants by astronomical standards. While stars live for billions of years, some planets begin forming almost immediately after their star ignites. These young stars are still wrapped in glowing clouds of gas and dust, surrounded by swirling disks where planets are actively taking shape. Tiny dust grains collide and stick together, forming pebbles, then rocks, then entire worlds. Some of these newborn planets still glow with leftover heat from their formation. Others continue to pull in gas and debris, growing larger day by day. Their orbits may be unstable, shifting as they interact with the surrounding disk. Their atmospheres may be thick, turbulent, and evolving. These are not finished worlds, they are planets in progress. Watching them is like watching the early chapters of Earth's own story unfolding in real time. Some planetary systems are far older than our own. Earth formed about 4.5 billion years ago, but we have discovered systems that are more than twice that age. These ancient planets have been circling their stars for 10 or even 11 billion years, surviving galactic collisions, stellar explosions, and unimaginable stretches of cosmic time. One such system, Kepler 444, hosts several small rocky planets orbiting a star older than the Sun itself. These systems are relics from the early universe, time capsules preserving clues about how the first planets formed when heavy elements were scarce. If life ever emerged there, it could be unimaginably ancient, perhaps billions of years older than life on Earth. In that sense, we may be late arrivals in a galaxy that has been quietly hosting worlds for eons. Some exoplanets are so massive that they challenge our very definition of what a planet is. These giants can be 10, 15, or even 20 times the mass of Jupiter, blurring the boundary between planets and brown dwarfs. Objects too small to become stars, but too large to be typical planets. These colossal worlds often orbit far from their stars, glowing faintly with residual heat trapped inside. Some may have dense cores buried beneath thousands of kilometers of atmosphere, while others might be almost entirely made of hydrogen and helium. Their gravity would be overwhelming, their storms enormous, possibly spanning entire hemispheres. Any moons orbiting such giants could be large enough to resemble planets themselves. These are the titans of planetary systems, quietly massive, slowly cooling, and profoundly mysterious. At the opposite extreme, some worlds are incredibly dense, so dense they could crush iron into exotic forms. These rocky exoplanets may be twice as dense as Earth or more, with massive metallic cores and extreme surface gravity. They may look like familiar rocky planets, with mountains, craters, and solid ground, but beneath the surface the pressure would be unimaginable. Walking on such a world would feel profoundly different. Your body would weigh far more, and the ground beneath your feet would feel unnaturally heavy, as though the planet itself were pulling you inward. These compact worlds are gravitational masterpieces, compressed into dense spheres of metal and stone. Then there are planets so light and puffy that they could float in water, if such an ocean existed. These low-density gas giants are enormous in size, but surprisingly lightweight, their atmospheres expanded by intense heat from nearby stars. Some have densities even lower than wood, making them cosmic bubbles drifting through space. Beneath their vast atmospheres may lie small, dense cores hidden deep within layers of gas. Their clouds may be thin and translucent, their winds slow and gentle. Despite their size, they are fragile giants, held together by gravity just strong enough to keep them from dispersing into space. Some planets may have lost their atmospheres long ago. A planet's atmosphere is delicate and vulnerable to radiation, stellar winds, and catastrophic impacts. Over billions of years, a planet can be stripped down to its bare rock. Small planets near their stars are especially vulnerable, their skies blown away by intense radiation. Without a protective magnetic field, their air can simply escape into space. What remains is a silent, exposed world, rock, dust, and perhaps ancient scars left by vanished oceans and vanished skies. These are planetary ghosts, stripped to their cores, circling their stars in quiet solitude. And some planets are still growing right now. Around young stars, thick disks of gas and dust can persist for millions of years, feeding growing planets. These worlds are still pulling in material, their gravity carving gaps and spirals in the surrounding disk. Astronomers have even captured images of planets in the act of formation, glowing faintly in infrared light. These newborn planets are hot, turbulent, and unfinished, their identities still forming. Watching them is like witnessing the birth of a world, a rare glimpse into the slow, patient process that once created Earth itself. And in the quiet swirl of dust and light, gravity continues its ancient work, shaping new planets that will wander the galaxy for billions of years to come. We have watched a planet die in real time. We often imagine planets as eternal, silent companions to their stars, but sometimes they are anything but permanent. In rare cases, astronomers have seen worlds fading away, their existence slowly erased by heat and gravity. One mysterious object observed by the Kepler Space Telescope dimmed and flickered in a way that suggested it was shedding its own material. It trailed a ghostly stream of dust, like a comet made of a disintegrating world. This small rocky planet was so close to its star that its surface was being scorched, its rocks vaporizing into space. Every orbit, it lost a little more of itself, leaving behind a fading signature in starlight. In another distant system, scientists detected a sudden burst of infrared light, possibly the aftermath of a colossal planetary collision. Two worlds may have collided, releasing enormous energy and scattering debris into orbit. These are not distant speculations or computer simulations. These are events we have witnessed across the vastness of space. We are seeing the final chapters of planetary stories unfold in real time. Some worlds are born before our telescopes. Others vanish before we can fully understand them. Creation and destruction, side by side, woven into the quiet machinery of the cosmos. Some exoplanets may experience snow unlike anything we know. On Earth, snow is soft, white, and made of frozen water. But on alien worlds, snow could be something far stranger, made of metal itself. In the upper atmospheres of scorching hot gas giants, elements like iron, titanium, and aluminum can exist as vapor. As temperatures drop at higher altitudes, these metals can condense into droplets and crystals. Under the right conditions, they could fall as metallic rain or snow, shimmering through alien skies. Imagine iron snowflakes, heavy and glittering, drifting through clouds lit by an orange or purple sun. Some planets may have clouds made of aluminum oxide, the same material found in sapphires and rubies. These mineral clouds could produce snowfall made of gemstones in microscopic form. Much of this snow would vaporize before reaching the surface, but high above, in the thin glowing skies, metallic particles would fall in silence. A strange weather system shaped not by water, but by extreme heat and exotic chemistry. Some planetary systems move in delicate gravitational dances. Not all systems are chaotic. In some, planets move with astonishing precision, locked into rhythmic patterns called resonances. One planet might orbit exactly twice for every 3 orbits of another, their motions synchronized like gears in a cosmic clock. These patterns emerge over millions of years as gravity gently nudges each world into a stable repeating path. In systems like TRAPPIST-1, where 7 rocky planets orbit a small star, this choreography is on full display. The planets keep time with one another, circling in quiet harmony, their gravitational tugs maintaining a delicate balance. These dances can last for billions of years, preserved in the darkness between the stars, long after civilizations rise and fall. Yet some systems are unstable, slowly drifting toward collapse. Not every planetary arrangement is balanced. Some systems appear precarious, with orbits that tug and stretch over time. Simulations suggest that certain planetary systems may unravel millions or hundreds of millions of years from now. Planets could be flung into interstellar space, hurled into their stars, or smashed into each other in catastrophic impacts. These systems are cosmic balancing acts, held together for now but destined to change. What we observe today may be a temporary arrangement, a snapshot in a long and dramatic evolution. Even planets, massive and ancient as they are, exist on shifting paths shaped by gravity's relentless hand. Some exoplanets follow tilted and unusual orbits. In our solar system, planets orbit in a relatively flat plane, like disks around the sun. But many exoplanets defy this pattern. Their orbits are tilted at steep angles, sometimes almost perpendicular to their star's equator. These tilted paths may be the result of gravitational encounters, ancient collisions, or close passes by neighboring stars. A planet might have formed peacefully, only to be knocked into a tilted orbit later in its history. Such tilts can influence climate, seasons, and stability, creating extreme variations in sunlight and temperature. From far away, we only see their present motion, but the tilt is a clue, a subtle hint that something dramatic happened in their past. Some planets spin backwards compared to their orbits. Planets do more than orbit. They spin on their axes, creating day and night. Most spin in the same direction they orbit. But some exoplanets rotate in reverse, spinning against the flow of their orbit. This retrograde rotation is likely the result of violent collisions, gravitational interactions, or tidal forces that flip their axes. Some even orbit their stars in the opposite direction of the star's own rotation. These backward worlds are rare and strange. Their days unfold in reverse, their weather patterns swirl in unfamiliar ways, and the sun would rise in unexpected directions. They are the rebels of planetary systems, quietly defying cosmic convention. We can even measure the winds on distant worlds. Without seeing these planets directly, astronomers can detect the motion of their atmospheres by studying subtle shifts in starlight. On some gas giants, winds reach astonishing speeds, hundreds or even thousands of kilometers per hour. These winds are driven by extreme temperature differences, especially on tidally locked planets where one side always faces the star and the other remains in perpetual night. Heat flows around the planet in massive jet streams, redistributing energy from the blazing day side to the frozen night side. Some planets may have storms that circle endlessly, never dissipating. Though we cannot hear these winds, their signatures appear in the faintest changes in light, a whisper of alien weather from across the galaxy. Some planets are bombarded by violent stellar flares. Not all stars are gentle. Young red dwarfs, in particular, can unleash powerful flares, bursts of radiation thousands of times stronger than those from our Sun. Planets orbiting close to these stars can be caught in a relentless storm of ultraviolet and X-ray radiation. Their atmospheres may be stripped away molecule by molecule unless protected by strong magnetic fields. Observations of stars like Proxima Centauri reveal dramatic flares, raising questions about the fate of nearby planets. Could life survive under such conditions? Could an atmosphere recover after repeated bombardment? These worlds remind us that habitability depends not just on distance, but on the temperament of the star itself. Others orbit calm and quiet red dwarfs. Not all red dwarfs are violent. Some are remarkably stable, slow-burning stars that shine gently for trillions of years. Around these calm stars, planets can orbit close enough to receive steady warmth without being blasted by flares. Their habitable zones are small but stable, offering long-lasting environments where life could potentially arise and evolve for unimaginable lengths of time. A planet here might be tidally locked, with one side in eternal day and the other in eternal night, but the twilight region between could host mild climates. These stars live slowly and quietly, offering planets a peaceful, steady glow, perhaps some of the most enduring homes in the galaxy. And some planets may be wrapped in auroras that never fade. On Earth, auroras appear when charged particles interact with our magnetic field, painting the sky with shimmering curtains of light. But on some exoplanets, auroras could be far more intense and permanent. Powerful magnetic fields and constant stellar winds could create glowing skies that never turn off, wrapping the planet in continuous waves of color. Entire hemispheres might glow with shifting light, day and night, a cosmic display stretching across alien skies. On some planets, auroras may never fade. Especially on worlds orbiting close to active stars, powerful magnetic fields can paint the skies with endless light. Instead of appearing only near the poles, these auroras could stretch across entire hemispheres, wrapping the planet in glowing rings and luminous bands. Imagine ribbons of green, blue, and violet light flowing across the clouds like a living ocean of color. On tidally locked planets, one side may burn under the relentless glare of its star, while the dark side glows with electric fire, a permanent night illuminated by cosmic energy. On massive gas giants with immense magnetic fields, these auroras might be visible from space itself, shimmering like halos around alien worlds. These skies are not quiet. They are alive, shaped not only by air and weather, but by the powerful breath of distant stars. We have also detected hints of clouds made not of water, but of vaporized rock. On some of the hottest exoplanets, temperatures soar so high that stone itself can melt into gas. Silicates, metals, and minerals rise into the atmosphere, condense into clouds, and drift across the sky like alien fog. Using spectroscopy, astronomers have identified unusual light patterns that suggest these mineral clouds exist, scattering starlight in unfamiliar ways. The skies of such worlds could shimmer with metallic haze, glowing with strange colors, golden, gray, crimson, or ash black. In the upper atmosphere, grains of rock dust might be carried by supersonic winds, forming storms of sand made from stone. These are not gentle clouds. They are forged from extreme heat and crushing pressure. On these planets, the sky is made of rock reduced to mist, drifting silently above landscapes that may never cool. Some planets are slowly falling into their stars. Orbits are not always permanent, and gravity never rests. On certain exoplanets that orbit dangerously close to their stars, tidal forces gradually drain orbital energy. Bit by bit, their paths shrink. Year after year, century after century, these worlds spiral inward, moving closer to their final fate. Astronomers have observed subtle changes in orbital periods, tiny shifts that reveal a planet's slow descent. Eventually, these planets will plunge into their stars, consumed in a final burst of light and heat. Their days may seem ordinary, their skies unchanged, but unseen forces are pulling them inward. These are worlds living on borrowed time, quietly descending toward an inevitable end. Others are not falling inward, but being flung outward into the darkness. In the chaotic early days of planetary systems, massive planets can gravitationally slingshot smaller ones away from their stars. A close encounter can eject a planet entirely, sending it drifting into interstellar space as a rogue world. These lonely wanderers have no sun, no warm daylight, no seasons. They drift through the cold between stars, invisible except for faint heat lingering within. Some may be as large as Jupiter. Others could be rocky and Earth-like, frozen into silent spheres of ice. Yet even without a star, they may still hold warmth deep inside, heated by radioactive decay or tidal forces. Beneath thick ice, subsurface oceans could exist in complete darkness. These are the ultimate nomads of the galaxy, traveling alone, carrying ancient secrets across cosmic distances. Some exoplanets follow orbits that stretch across entire star systems. While most planets stay relatively close to their stars, others travel on vast, sweeping paths that take centuries or even millennia to complete a single orbit. These distant worlds move slowly, tracing enormous loops through space. Some swing close to their star before drifting far back into the dark. Others remain on the fringes of their systems, barely held by gravity. These extreme orbits may be the result of ancient migrations, collisions, or gravitational disruptions. Astronomers have detected planets hundreds of astronomical units away from their stars, so distant that their suns appear as tiny points of light. These planets live on the edge, where space is quiet and time moves slowly. Some planets exist in the delicate Goldilocks zone, where conditions are just right. Between the burning heat near a star and the frozen darkness far away lies a narrow region where temperatures allow liquid water to exist. This is the habitable zone, sometimes called the Goldilocks zone. Not too hot, not too cold. Earth resides in this precious region, and many exoplanets have been discovered there as well. These planets receive just enough light to maintain stable temperatures, making them promising candidates for life. But being in this zone does not guarantee habitability. Atmospheres, rotation, oceans, and geology all matter. Still, these worlds are among our best hopes for finding life beyond Earth. They orbit quietly, balanced between fire and ice, suspended in a gentle glow of possibility. We have even identified planets that may have Earth-like temperatures. Some exoplanets not only orbit in the habitable zone, but also appear to have surface temperatures similar to our own world. Planets such as Kepler, 442b, and TOI 700d intrigue scientists because their climates might allow liquid water and moderate weather. We do not yet know their atmospheres or surface conditions, but temperature offers a tantalizing hint. These worlds might have oceans, clouds, and gentle winds. Rain might fall under alien skies. Sunsets could paint unfamiliar colors across distant horizons. We cannot see these planets up close, but we can imagine standing there, beneath a foreign sky that feels strangely familiar. Some exoplanets may experience weather beyond anything we know. Weather is shaped by chemistry, heat, and atmosphere. And when those factors change, the results can be astonishing. On some worlds, clouds might be made of molten metal, and rain could fall as liquid glass or methane. Winds might reach incredible speeds, racing around the planet faster than sound. On cold planets, snow could fall as ammonia crystals. On scorching worlds, dust made of silica might fill the air, turning the sky opaque. Lightning could strike through clouds of vaporized rock. Storms might last for centuries, and jet streams could circle the planet forever. These are not Earth-like climates. They are alien systems built from unfamiliar physics, beautiful, extreme, and almost impossible to imagine. Other worlds may hide ice volcanoes and secret oceans beneath frozen surfaces. Not all volcanic activity involves fire and molten rock. On icy planets and moons, volcanoes can erupt with slushy mixtures of water, ammonia, or methane. These cryovolcanoes have been observed in our own solar system, and similar processes likely occur on distant exoplanets. Beneath thick ice shells, hidden oceans may remain warm for billions of years, heated by internal energy. These underground seas could host complex chemistry and perhaps even life. The surface may be silent and frozen, but deep below, water flows, cracks open, and something moves in the dark. A hidden ocean, dreaming beneath a world of ice. Some worlds exist in the quietest corners of the galaxy. The Milky Way is full of motion, stars orbiting the center, clouds collapsing into new suns, planets circling endlessly. But some regions are calm and remote. In the outer edges of the galaxy, far from crowded spiral arms and violent radiation, stars move slowly through ancient darkness. These are the galactic suburbs, dim, quiet, and old. Planets orbiting these distant stars may live in peaceful isolation, rarely disturbed by stellar encounters or cosmic chaos. In these silent regions, worlds may exist in near-perfect stillness, turning slowly under faint starlight, untouched for billions of years. These planets may follow calm, unchanging paths for billions of years. With no nearby stars to disturb them, no violent tides to twist their orbits, they simply continue their slow, quiet journey around their suns. In these peaceful systems, time stretches endlessly. If life were to emerge, it would have countless ages to grow, evolve, and adapt. Nothing would rush it. Nothing would force sudden change. These distant worlds may be cold and dim, but in their stillness, they offer something rare in the universe, a gentle stability, a cosmic shelter where something enduring could quietly take root. But not all planets are so fortunate. Some race through crowded, chaotic regions of the galaxy. In dense star clusters, spiral arms, or near the galactic core, stars pass dangerously close to one another. Gravity tugs, orbits wobble, and planets can be torn from their paths or stolen by passing suns. A world in such a crowded starfield might see dozens of stars in its sky, bright and ever-shifting. The night might never truly be dark, but this beauty comes with danger. A nearby supernova could strip away an atmosphere in an instant. A passing star could fling a planet into deep space. These planets live on the edge of cosmic chaos, dancing through a crowded ballroom of burning suns, surviving one close encounter after another. Some of the strangest planets ever discovered orbit pulsars, dead stars that pulse like cosmic beacons. Pulsars are neutron stars, the dense cores left behind after massive stars explode in supernovae. They spin incredibly fast, sending out rhythmic beams of radiation like celestial lighthouses. No one expected planets to exist around such violent remnants. And yet, the first confirmed exoplanets were found around a pulsar called PSR B1257+12. How these planets formed is still a mystery. They may be survivors of the original system, or they may have formed from debris that settled after the explosion. Either way, they orbit stars that no longer burn, only pulse. Ghost planets circling ghost stars. Silent worlds tracing paths around the afterglow of stellar death. Some planets may have even survived nearby supernova explosions. Supernovae are among the most powerful events in the universe, capable of destroying entire systems. But in some cases, planets endure. A planet in a binary system might remain after its companion star explodes, scorched but still bound to the surviving star. Others may form later from the scattered debris of the explosion itself. Astronomers have found traces of heavy elements in the atmospheres of white dwarfs, suggesting that planets once orbited them, and perhaps still do. If any world survived such devastation, it would carry the scars of catastrophe. Its surface altered, its atmosphere transformed, a witness to destruction and survival in the same breath. There are also worlds with atmospheres unlike anything we know. Earth's air is gentle and familiar, mostly nitrogen with oxygen, water vapor, and traces of other gases. But elsewhere, skies can be alien. Some atmospheres are thick with hydrogen and helium. Others contain methane, carbon monoxide, sulfur compounds, or exotic metallic vapors. One planet shows hydrogen escaping into space like a glowing comet tail. Another hints at titanium oxide in its skies. These gases shape everything: the color of the sky, the weather, the temperature, even how light behaves. Some atmospheres may be clear and shimmering, others thick, dark, and suffocating. Some may look simple from afar, but hide layers of chemical complexity beneath. Air across the cosmos is not always blue or breathable. Sometimes it burns, sometimes it shines, sometimes it is stranger than stone. Some planets may be rich in carbon and poor in oxygen. On Earth, oxygen drives life, but in other systems, carbon may dominate. Carbon-rich planets could have landscapes of graphite, diamond mountains, and oceans of hydrocarbons. Their skies might carry methane clouds instead of water vapor. Their surfaces could sparkle with unfamiliar minerals never seen on Earth. Other planets might lack oxygen entirely, with iron-heavy crusts and carbon-based chemistry shaping their worlds. If life exists there, it would follow rules unlike ours, telling a completely different story of biology. These worlds remind us that Earth is not the blueprint for all planets. Some are forged from different cosmic recipes, shaped by different histories, built on different elements. We are only beginning to search for signs of life on distant planets. Scientists call these hints biosignatures, chemical clues that living organisms might be present. On Earth, oxygen, methane, and water vapor exist in a delicate balance that biology helps maintain. Now, astronomers are scanning exoplanet atmospheres for similar patterns. Using powerful telescopes, they split starlight into spectra, searching for faint fingerprints of life-related molecules. It is difficult work. Clouds, temperature, and stellar activity can mimic biological signals. But some planets show promising signs: water vapor, unusual carbon compounds, and intriguing chemical imbalances. Future missions will search for ozone, plant-like pigments, and other subtle clues. We haven't found life yet, but for the first time in history, we are truly listening for it, watching for the faintest whisper of biology across the cosmic dark. Some exoplanets may be wrapped in dust storms that never end. On Earth, dust storms come and go. On other worlds, they may last for years or forever. Dry landscapes and powerful winds lift fine particles into the air, swirling endlessly around the planet. The sky might glow copper, brown, or gold. The sun would appear dim behind the haze. From space, the planet could look smooth and soft, its surface hidden beneath drifting dust. These storms shape climate, chemistry, and light, creating an environment where life would need to adapt not to rain or snow, but to constant drifting grit. Others might shine brilliantly, reflecting starlight like cosmic mirrors. Some planets are dark and hard to see. Others are dazzling. Highly reflective clouds, icy surfaces, or exotic compounds can make planets glow intensely. A world covered in silicate clouds might gleam like polished stone. Others may reflect light like metal or crystal. These planets can appear brighter than snow, brighter than Venus, glowing with borrowed light from their stars. They don't generate light, but they echo it, shining like beacons across interstellar space. And some planetary systems look surprisingly familiar. Not every system is chaotic. Some resemble scaled-up versions of our own solar system. Small rocky planets orbit close to their stars. Gas giants sit farther out. Asteroid belts and icy outer regions form natural boundaries. These familiar patterns suggest that planetary formation may follow universal laws. Gravity shapes dust into worlds. Time arranges chaos into order. And across the galaxy, solar systems may quietly mirror the structure of the one we call home. Rocky planets often form close to their stars, where heat is strong and heavy materials can survive. Farther out, where temperatures drop, gases gather and giant planets take shape. This pattern feels strangely familiar, almost comforting. It suggests that our own solar system may not be an exception, but a pattern repeated again and again across the galaxy. Perhaps other planetary systems follow a similar rhythm. Perhaps our cosmic neighborhood is echoed in countless distant star systems, each one humming its own quiet celestial melody. We don't yet know if these worlds have moons, oceans, or living skies. We don't know if they hold storms, continents, or something stranger than imagination. But when we study their structure, we recognize something deeply familiar. It feels like a reflection of home, a reminder that our place in the universe may not be as rare as we once believed. And yet, many planetary systems refuse to follow any pattern at all. Some systems defy every rule we thought we understood. Gas giants orbit scorchingly close to their stars, closer than Mercury ever dared to be. Some planets tilt at extreme angles, loop through stretched and twisted paths, or even orbit backward against their star's rotation. There are systems packed with more planets than we thought physically possible. Moons that rival planets in size. Worlds that migrate across their systems, reshaping everything in their path like cosmic travelers rewriting history. These strange architectures challenge every neat model scientists once built. They suggest that planet formation is not tidy or predictable. It is messy, dynamic, creative. Each new discovery adds another variation to the cosmic story. Each system writes its own version of how worlds can form and survive. The more we learn, the more complex and astonishing the universe becomes. It's as if the cosmos is not following a script. It's improvising, building worlds in ways no one ever imagined. And now we are beginning to see these worlds with our own eyes. Until recently, exoplanets were detected only indirectly. We noticed stars dimming slightly, or wobbling under invisible gravitational pulls. We inferred planets from shadows and signals. But a new era is beginning. Scientists and engineers are constructing telescopes powerful enough to directly image these distant worlds. They will use coronagraphs to block out starlight. They will deploy enormous star shades to create artificial eclipses in space. The goal is simple, yet profound: to see an exoplanet as a tiny, faint point of light next to its star. From that faint point, we can study atmospheres, analyze chemistry, and search for hints of life. Missions like the Nancy Grace Roman Space Telescope and future concepts like LUVOIR and HABEX aim to capture true portraits of alien worlds. Soon, exoplanets will no longer be invisible ideas. They will be places we can see. In fact, it has already begun. Astronomers have managed to directly image a handful of exoplanets, massive gas giants far from their stars. These images are blurry, faint, and indistinct. They show no continents, no clouds, no oceans. But they are real. We have seen the warm glow of planets still cooling after their birth. We have watched distant giants slowly trace their orbits over years. The HR 8799 system was among the first glimpses, a historic moment when humanity saw light from a world beyond our sun. As technology improves, these faint dots will sharpen. One day we may see storms, oceans, or even continents. For now, we have a blur, a whisper, a beginning. When we search for life, we almost always begin with planets. We imagine air, water, sunlight, and time. We search for worlds in the habitable zone. We scan for oxygen, methane, and strange chemical signatures. Each detection raises questions. Could this planet have liquid water? Could microbes exist there? Could anything live beneath its sky? Even the smallest hint, a spectral wobble, a faint absorption line, can send excitement through the scientific community. Because if life exists elsewhere, it will likely be on a planet that quietly turned for billions of years, unnoticed. Exoplanets are our windows, our mirrors, our best chance to answer the question, are we alone? And with every discovery, the universe becomes stranger. We expected Earth-like worlds. Instead, we found lava planets, rogue wanderers, frozen giants, and molten skies. We found tightly packed systems, planets orbiting dead stars, and weather systems that defy imagination. Each new world adds another surprise, another reminder that the cosmos is endlessly inventive. And the planets we know, just a few thousand, are likely a tiny fraction of what exists. The galaxy is filled with wonders still hidden. The universe is not simple. It is not predictable. It is creative beyond measure. And by exploring these distant worlds, we expand our imagination, learning to find beauty in the unfamiliar. There may be more planets than stars in the Milky Way. For centuries, we thought planets were rare companions to stars. But today, evidence suggests the opposite. Most stars likely host planets. Many host several. This means there may be hundreds of billions of planets in our galaxy alone. Some are massive, some are tiny, some are scorching, some are frozen in eternal night. But together, they form a cosmic garden, a vast collection of worlds, each following its own path through space. Each one a quiet possibility, and among them, some may be blue. Some may have air. Some may be alive. Somewhere out there, a world like Earth might be waiting. We don't know where it is. We don't know what it looks like. But the odds are in our favor. Among countless stars and countless planets, some must be rocky, warm, wet, and alive. Maybe it orbits a red dwarf. Maybe a sun like ours. Maybe it has forests and oceans. Or maybe life there looks nothing like anything we recognize. Maybe civilizations rose and fell while Earth was still molten rock. We haven't found that world yet, but we are searching. Every telescope, every mission, every discovery brings us closer. And when we finally find that distant twin, it will change everything. It will remind us that we are not alone in the cosmic dark, that other Earths exist, that the universe is not empty but shared. And now, our journey draws to a gentle close. Tonight, we traveled far beyond the warmth of our sun. We drifted past familiar skies and into a galaxy filled with silent worlds. We wandered through endless dust storms, glowing skies, frozen oceans, and atmospheres made of metal and cloud. We watched stars flare and fade. We saw planets cast into darkness and imagined life quietly taking root in distant places. And through it all, one thought remained. The universe is not only vast. It is full of places. Places with gravity and weather. With histories and futures. With stories still unfolding in silence. Each exoplanet we visited tonight, real, theorized, or barely glimpsed, was its own small world. A tiny island of gravity in a sea of starlight. A quiet question waiting to be noticed. And perhaps that is the wonder of it all. Even as you rest here, safe and still, the cosmos continues. Stars are shining. Planets are turning. And somewhere far away, a world not unlike ours is spinning slowly through its night. So if your eyes are growing heavy, if your breath is slow and steady, if your thoughts are drifting like dust in the dark, you don't need to return. You're already part of this universe, already floating, already home. Thank you for sharing this quiet journey among distant worlds. And if it helped you rest, you are always welcome to return, to listen again, to dream again, to keep wondering. And if you are still awake, you can watch the next video. There are always more wonders waiting, more science, more stillness, more stars. But for now, rest. The planets will keep turning. The universe will wait. Good night.